Today we're looking at using corresponding parts of congruent triangles. And that piece is missing a C here. This should be CPCT is what it should say. So, earlier we learned if all corresponding parts of a figure are congruent, then the figures are congruent. Today we're looking at the converse of that postulate. So, in other words, if the figures are congruent, then the corresponding parts are. So, CPCTC is short for corresponding parts of congruent triangles are congruent. So, notice that that's using just the first letter of each word. It's just so that we don't spend a long time writing everything out. We abbreviate everything. So you're going to want to know that abbreviation, CPCTC. It's intended as an easy way to remember when you have two triangles and you've proved that they're congruent, then each part of one triangle is congruent to the corresponding part in the other. So looking at this picture right here, we're going to try to tell why the two triangles are congruent, which is the stuff we looked at before, right? Your side, angle, side, your angle, side, angle, your side, 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 and your angle, angle, side postulates. So you're going to want to make sure you're keeping that stuff handy. So looking at this this picture, I have a side and an angle, and then I look at what else I can show. Well, these are vertical angles, so then I know they're congruent. So this is an angle, angle, side. So by angle, angle, side, I know that triangle KLM is congruent to triangle KJH. And remember, you have to make sure that these match up. Oh, I forgot the little triangle piece there. That these match up. So K is where the pink marking is, so that's the first one for each triangle. Then I went to the angle that is indicated as congruent with each other, so L and J. See how they're in the middle? And then I went to the last side, or the last angle. So make sure you're doing that in the right order. Then after you do that, you're supposed to list all of the corresponding parts, so all the pieces that match up. So we already know that angle J and L are congruent. And we know angle K is congruent to itself. Why? Because it's a reflexive property. And we know that the other angles are congruent because of our theorem that says if two angles in one triangle are congruent to two angles in another triangle, then the third angle is also congruent. So again, we need to make sure we're memorizing that information. So those are all my angles. So then looking at my sides, I have JH is congruent to ML, because they're marked that way. And then going from the already given side angle to the vertical angle, J to K, I go from L to K, so from JK is congruent to LK. And then my last side is from HK to KM. HK is congruent to KM. Now, why do I know that? Because corresponding parts of congruent triangles are congruent. So I didn't use these to prove the congruency of the triangles. From the triangles, I can say any of these things. Okay, you give it a try. So pause the video, complete your diagram, fill out your answers, and come back to me. Did you get that? Check your work, make sure it matches. Make sure your image matched the picture I have there. Okay, going on to the next piece. We're going to do a proof. We're going to prove that two pieces are congruent. Well, because I have triangles, I'm going to guess that I'm probably going to have to prove that the triangles are congruent to prove that the segments are congruent. So, what do I know? They tell me that YA and YB are congruent, which is marked, and the angle B and angle Y are congruent, which is also marked. What don't they tell me? Well, they don't tell me that angle AYAZ and angle CAB are congruent, but they are because they're vertical angles. So, following our process over here, segment YA is congruent to segment BA, and angle B is congruent to angle Y because it is given. Then angle YAZ and angle BAC are vertical angles. That's definition of vertical angles, right? Two lines that cross. Angle YAZ is congruent to angle BAC because vertical angles are congruent. Then now I have my sides and my included angle. My angles and my included side. So I have by angle, side, angle. My triangles are congruent. So I'm going to have triangle ABC is congruent to triangle AYZ. AYZ. And you have to make sure that the corresponding pieces match up. So why did I say that? Because of angle, side, angle postulate. Now, because the two triangles are congruent, I can say that these segments, if they're corresponding, well, AZ and AC are corresponding parts. So because they're corresponding parts, they are congruent. So over here, I'm going to say corresponding parts of congruent triangles are congruent. Alrighty, here's yours. Give it a try. Did you get that? Check your answer, make sure it matches. Okay, moving on to the next piece. This time we're going to do a proof, but we're going to add in a construction. A construction is when I build a piece of information into my proof that isn't already there. Why would I do that? Well, because sometimes it helps me prove what I need to prove. So let's start with what they give me and then figure out what I need to construct. But this tells me by the directions that I'm going to have to use a construction. So, using a construction, prove that the two base angles, to prove that the two base angles of an isosceles triangle are congruent. So I'm going to prove that A and C are congruent. So first of all, I'm going to say that it's a given that it's an isosceles triangle. So that tells me that these are congruent, right, by definition of isosceles triangle, but it's a given. Because it's a given, AB and AC and CD are congruent, which I just marked. Then I'm going to construct the midpoint. Why would I choose that? Well, because if I put a midpoint here, and I draw it from here to here, I'm going to call the midpoint D, and I draw it from B to D, this becomes a median of my triangle. From a vertex to the midpoint of the opposite side is a median. And what do medians do? They bisect the angle. That's the big thing. It bisects this angle. So I've constructed the midpoint of AC and called it D. And the reason I did that was because it's a construction. So I just basically named or labeled something into my picture. Now I'm going to be able to say, well, what does a midpoint do? It tells me, when I create it, that these pieces are congruent. Why? Because I built it that way. So that's the definition of a midpoint. So I have AD, segment AD is congruent to segment DC. So I have a side and another side. BD is congruent to itself because of the reflexive property of congruence. From that, so now looking at my picture, I have a side thing going on here, so I can say that my triangles are congruent. Why? Because of the side postulate, which says that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So now I've proved my triangles are congruent. So then my corresponding parts are congruent. So my triangle is ADB, oh, it's already written, ADB is congruent to CBD because of the side-side-side postulate, and now I can simply say that angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. So that's how you would use a construction to complete a proof. If you have any questions, let me know.